Hello everyone, this is the first lesson recording for IM2, January 11, 2021. We started off by doing some warm-up exercises on the decimals, so card number 1 to 2 of the decimals. So please pause the video and make sure you get this done. Okay, the first card is a card sort where you are matching the quadratic expression with the factored form. Well, when I look at 4x plus 1 times 4x plus 1, I know that the first term has to be 4x times 4x. So I am looking at 16x squared, which is the one with 16x squared. That's the only one. So I'm going to match that up. Okay. you know, think smartly. Don't try to, where you know that you can eliminate some things, you should certainly do that. Certainly, if you can factor 16x squared plus 8x plus 1 using either the area model or the grouping method, that would be great too. Okay, 4x squared minus 20x plus 25. Well, if I multiply 2x times 2x, I am going to get 4x. But I am also going to get 4x squared if I get have multiplied 2x times 2x here. So I also need to look at the last terms. I see 3 times 3. I know that the last term has to be positive 9. So it matches with this. And, okay, this one, 5 times negative 5 times negative 5 is positive 25. So it matches with this. And then finally, 3x times 3x should be 9x squared. And 1 times 1 should be positive 1. So here we go. And it should give you a feedback as to whether you got all of them correct or some of them incorrect. I then went on to give an announcement. You are going to have a quiz next class. It's going to be on factoring, GCF, that's from last year, and the quadratic factoring when a is equal to 1, as well as when a is not equal to 1, that's where we learned either the area model or the grouping method. Either of the method will be fine for you to use, but there will not be any special patterns yet. Okay, you are going to be tested on this, but nothing from today. So no, all the material from today will not be on the quiz next class. It will be handwritten and it's going to be submitted. So you're going to have to do that. All right, so what are we doing today? We are going to be looking at quadratics with special patterns, specifically perfect square trinomials and difference of squares, and other miscellaneous concepts such as what is a standard form versus factored form, and quadratics factorable or not factorable, and factor completely. What does it mean to factor completely? And we may practice using different strategies. All right, so factoring special quadratics number 1, perfect square trinomial. To explore this, you're going to work on card number 3 to 7 of the decimals. Please pause the video and try them yourself now. Okay, so this is card number 3 of the decimals. I want you to read this carefully and see if you can process it. All 4 quadratic expressions in the card sort from the warm-up, that's card number 1 that you did, are examples of perfect square trinomials. To explain the name, we first notice that both their factors are the same, so we can be written as square. So for example, the first example, 4x squared plus 12x plus 9, the factors are 2x plus 3 and 2x plus 3. So it is written as 4x squared plus 12x plus 9 is equal to, that means it's equal in value to 2x plus 3 in parentheses multiplied by 2x plus 3. Since the expression inside the parentheses is the same, we can just rewrite this more efficiently as 2x plus 3 all squared. Okay, whatever the expression is inside the parentheses is being multiplied to itself twice. That's what it means. The next 16 is called the perfect square number. Okay, remember 16 is a perfect square number, as is 9, 16, 25, 36, 64. Those numbers are all called perfect square numbers because it can be written as something squared. 16 can be written as 4 squared. So similarly, 4x squared plus 12x plus 9 is called perfect square trinomial because it can be written as 2x plus 3 all squared, something all squared, right? So that's what we mean by perfect square trinomial. And visually, it means that 2x plus 3 is the length of a square, and 2x plus 3 is also the width of the square. So we're talking about a square. That's why it's called perfect square. Okay, moving on. Card number 4. The perfect square trinomials have the following attributes. Okay, so looking at all those 4 examples that we saw, you must have all 3 terms. Okay, you can't just have 2 terms, you need to have all 3 terms. And the x squared term, coefficient, and the constant term are both positive and perfect squared numbers. That means the very first terms, like 4x squared, 16x squared, 9x squared, they're all perfect squared. Okay, because 4x squared is 2x all squared, 4x squared is 2x all squared, 16x squared is 4x all squared, and 9x squared is 3x all squared. Okay, as is the last term. As are the last term, the constant terms, 9, 25, and 1. They're all perfect squares themselves. Okay, and they have to be positive. Okay, because you can never get something square to be negative. If it's not enough that they're perfect square, it has to be positive perfect square. And then third criteria is that the x term number is 2 times as the product of the square roots and it can be positive or negative. That means if I take a square root of 4x squared, what is it? That's 2x, right? And what is the square root of 9? That's 3. So 2x times 3 and then multiply that by 2. Okay, 2x times 3 is 6x. Now 6x times 2 is 12x. So it has to be that number. Okay, what about this? Square root of 4x squared is 2x. Square root of 25 is 5. 2x times 5 is 20. And 2x times 5 is 10, I'm sorry. And 10 multiply that by 2 is going to be 20. But this can be positive or negative. Okay, the sum can be positive, negative, unlike the first term and the last term has to be positive. And then likewise, 16x squared, square root of that is 4x. 4x times 1 is 4x. 4x times 2 is 8x. So you are doubling the x term number is 2 times. That's why I am doubling the product of the square roots. Likewise, the product of the square roots, 3x times 1 is 3x. Now I need to double that. 3x times 2 is 6x, but 6x can be positive or negative. Okay, and I'll show you how that happens. All right, so then which are perfect square trinomials? Okay, so using those 3 criteria, remember the first terms have to be perfect squares, and the last terms have to be perfect square. And not only that, they have to be positive perfect square. And the middle term has to be double of multiplying the square root of the first term and the square root of the last term. So square root of the first term is just x times square root of the last term is 5. 5 times x is 5x, and double that is 10x, but this can be positive or negative, so I am going to check that off. What about this? Square root of 4x squared is 2x. 2x times square root of 36, which is 6. 2x times 6 is 12, and double that is 24. This has to be 24, not 9x. So this is not a perfect square. 9x squared, square root of that is 3x, times square root of 4 is 2. 3x times 3, 2 is 6x, and double that is 12x. Can be positive or negative. Happens to be positive, that's fine. What about this? This fails because we need 3 terms. We only have 2 terms. This is not it. What about this? 9x squared minus 4. Remember, the first term and the last term, they have to be perfect squares as well as it needs to be positive. So this fails there. So we only have two that are correct. And these are the options that you should have. Okay, now factoring the perfect square trinomial. Okay, so try to factor 9x squared minus 24x plus 16 by the similar pattern. Okay, so to do this, what is the square root of 9x squared? That's going to be 3x. What is the square root of 16? It's 4. Oops. Okay, whether it's going to be positive or negative depends on the middle term, whether the middle term is positive or negative. Okay, so it's going to be 3x plus 4 and 3x plus 4, or 3x minus 4, or 3x minus 4. I do not know that. But now let's just check if the middle term adds up. Square root of 9x squared is 3x times square root of 16 is 4. So 3x times 4 is 12x, and doubling that is 24x. Okay, and yes, 24, I have 24. The only way I can get negative here is if it's 3x minus 4, right? So it's going to be 3x minus 4 here and 3x minus 4 here. And those are my factors, which is same as saying 3x minus 4 all squared. Okay? And I'm going to submit that. Okay, I'm going back to the slides to quickly summarize all that you should have covered for yourself. So if you have 4x squared plus 12x plus 9, it's named because it can be written as a binomial squared, some expression all squared. It's called perfect square because of that. Such as 4x squared plus 12x plus 9 can be written as 2x plus 3 in parentheses all squared. And you must have all three terms. And x squared coefficient and the constants have to be positive. So the first term, the x squared term, and the constant, the very last term, have to be positive. It cannot be negative. Why? Because when you multiply two numbers, you're never going to get negative as a result. The x squared term and the constant are perfect squares. So the 4 is a perfect square, 9 is a perfect square. Such as 4 is a 2 squared and 9 is a 3 squared. X term coefficient can be positive or negative. Twice the product, the square root. So the middle term can be positive or negative, okay? But it has to be twice. That means what? Double of the square root of the first term and the square root of the last term. So square root of the first term is 2x. The square root of the last term is 3. 2x times 3 is 6x, and doubling that gets you 12x, and that is the pattern that you need. And that 12 is 4 square root of 4, which is 2, times square root of 3, 9, which is 3, 2 times 3, and we have to double it. That's where the first 2 comes from, and that is 12. Okay, so factoring perfect square trinomial. For both perfect square numbers, decide the square root. Okay, so what is the square root of 4? That's going to be 2. What's the square root of 9? That's going to be 3. And then use the factor as template. Okay, so that's going to be 2 goes there, and then 3 goes here. And whether it's going to be positive or negative depends on the middle term. Is the middle term going to be positive? Is the middle term positive, or is it the middle term negative? If this was negative 12x, then this will be 2x minus 3 all squared. Factoring perfect square trinomials, okay? For both perfect square numbers, decide the square root. Okay, so in this case, because the middle term is negative 20, and it's going to be minus 5. Okay, So now you're going to pause the video and complete card number 8 to 10. And I'll continue in the next lesson recording.